Alright, here we go with solving systems by substitution. So you remember doing some substitution maybe when solving systems of equations that were just both linear? It's very similar when you're using a quadratic and a linear equation. Okay, so let me show you what I mean here. We've got a quadratic and a linear equation, and our goal is to solve and figure out what the x should equal and what the y should equal. Once we do that, technically if we go back and plug those numbers in for x and y, we'll get back a true equation in both of the equations. Okay, so the first goal is to solve for one of the variables. Now, you'll notice this first equation is already solved for y, and in my opinion, when you've got a quadratic equation involved in your system, I think it's easiest to solve both equations for y. So let me show you why I want to do that. Okay, so I'm going to solve this equation for y, meaning I'm going to isolate the y, which it's not isolated. I need to move the x over. So I'm going to minus x to both sides. And I end up with y on the left, and I'm going to go ahead and write it like this because I like to keep my x's in the front. Negative x plus 5. This is a positive 5 here, so that's why it ends up being plus 5. Alright, so now I've got two equations equal to y. Interesting, okay, because I can actually say, well, if this one equals y and this one equals y, then they should equal each other, right? So I'm basically going to take this expression and substitute it in here, where y is. So again, it's substitution. I'm just substituting an expression for another expression. So here was what I've got. And you're thinking, this looks pretty horrible, but it's going to be okay. Let's go ahead and do it. Alright, I've got x's on both sides. I better move some x's over. I'm going to keep my x squared over here because I like it positive, so I'm going to go ahead and choose to add this x to both sides. I'll do that in one step so you can see all the steps one at a time. I got minus 5x here because negative 6 plus 1 is negative 5 plus 9. And on the right side, I'm only left with a 5. Now, it's best to solve a quadratic equation when it's equal to 0. So I'm going to go ahead and move my 5 over as well. I'm going to choose to write it here underneath the 9 because those are like terms. Okay, so 5 minus 5 is 0. That'll do it. And then I've just got to use maybe the quadratic formula or something. So here I've got an x squared, here I've got a minus 5x still, and then I've got a positive 4 it looks like, because 9 minus 5 is positive 4. Okay, so this is cool. I'm here. There's more than one way to solve this type of equation, but I think the way that most people are familiar with at this point in the course is to use the quadratic formula. So I'm going to identify a, b, and c. A equals 1, b equals negative 5 because that's the number in front of x, c equals 4 because that's the constant. Okay, and you'll remember the lovely quadratic formula. Give me a second to write it out. Alright, there we got it. So I'm going to be plugging in. I like to put my x equals because this is going to be what x equals at the end. X is going to be negative b, or the opposite of b, which my b is negative 5, so I'm going to put a negative 5 or a positive 5 here, opposite of b. Okay, plus or minus the square root of b squared, well, b was negative 5, so plug that in, minus 4 times a, which is 1, times c, which is 4, all over 2 times a. Remember, a is 1. Okay, so here we go. Let's keep solving or simplifying. 5 plus or minus, I got to do all this stuff on the inside. Negative 5 squared, negative 5 times negative 5, positive 25, minus 4 times 1 times 4. Well, 4 times 4 is 16, so 25 minus 16, all over 2 times 1, which is 2. Again, I'm still solving for x, so 5 plus or minus the square root of 25 minus 16. Well, that's going to be 9 over 2. So x equals, well, square root of 9 is 3. I can do that. 5 plus or minus 3 over 2. And here's where I might split it into two equations. Okay, so I can either do x equals 5 plus 3 over 2, or x equals 5 minus 3 over 2. Okay, and I'm going to solve this first one. 5 plus 3 is 8 over 2. 8 over 2. That equals 4. So I could have that x equals 4. Or I could do 5 minus 3, which is 2 over 2, and that equals 1. I'm running out of room. Just in time. Okay, so we got that x could equal 4, or x could equal 1. And we would say we're all done, except we're not, right? Because we're supposed to find what x and y equal. So if you remember, substitution involves a lot of substituting. So we're going to take those numbers and plug them back into one of our equations. I am going to choose to not use the quadratic because it looks like more work to me. Okay. I could use this equation that y plus x equals 5, or I could use this one that's already solved for y. Any equation that has a y and an x in it is eligible to be used to figure out what one of the variables equals. Okay, so I'm going to choose this one right here. So I'm going to be plugging my numbers, my yellow x's, into this equation. Okay, so I've got, if I plug in 4 there, negative 4 plus 5. Okay, so this is for x equals 1. Oh, excuse me, it's for x equals 4, isn't it? Because I'm plugging in 4. Okay, negative 4 plus 5 for y, that's a positive 1, so y equals 1. So right here is one of my solutions. X equals 4, y equals 1. I could even write it as a point, because remember, if I graphed this, this is where one place where the two graphs would intersect. Let's do it again over here. Now I'm going to plug in x equals 1 into this equation. Y equals negative 1 plus 5. Okay, so then y is going to equal 4, it looks like. Interesting. Okay, so I got x equals 1, y equals 4. If I were to write that as a point, it would be 1 comma 4. And I'll just point out, of course, it is coincidence that we got 4 comma 1 and then we got 1 comma 4. It doesn't usually end up like that. But those are two solutions. If I plug those numbers back in to x and y, my equation would be true for both equations. Alright, so that's it. That's how we solve systems of equations by substitution. We've got one more to go over, which is solving systems by elimination. So you're going to get to choose which method you prefer the most and then use that. Okay, so good luck with that one. Thanks for watching about substitution.